Thevenins theorem. This is part of circuit analysis, semester 1. In today's session, we are going to discuss about Thevenins theorem and how to apply Thevenins theorem on a given bilateral network with two examples. Let us start with the objectives of this particular topic. We'll introduce you what is meant by Thevenins theorem. I will give you the statement and explanation part of the Thevenins theorem, and it involves finding equivalent resistance and finding open circuit voltage, which is also called as Thevenin's equivalent voltage. We apply this Thevenin theorem on various circuits. Very particularly, we consider two circuits. We apply this Thevenin theorem on both the circuits one after the other. In the first part of my explanation, I will consider one example and I will show you how to Thevenize it. In the second part of my video, you will see the Thevenization process of the second circuit. So let us start with the introduction. As I told you, the Thevenin's theorem is a mathematical technique which is going to replace the entire network with one voltage source in series with the equivalent resistance. So if you see the block diagrammatical representation of the network, this network may contain any number of voltage sources, any number of current sources, resistors connected in any manner. According to Thevenin's theorem, we can replace this network with one voltage source VTH and one resistance, equivalent resistance RTH in series with each other. So you can see VTH and RTH both are in series, and not only in series, they are in series with the load resistance also. So what according to the Thevenin's theorem is, according to Thevenin's theorem, any linear bilateral network containing any number of voltage sources, current sources and resistors connected in any manner can be replaced by a voltage source in series with the resistance. That's what I discussed. This network can be replaced with one voltage source in series with equivalent resistance RTH. So instead of considering this entire network, this is an equivalent of this entire network. So after replacing the equivalent, you can find the current flowing through the load resistor RL. You can find the current IL using the formula IL is equal to VTH by RTH plus RL, where RTH is the equivalent resistance, VTH is the open circuit voltage or Thevenin's equivalent voltage. RL is also called as the load resistor, right? Let us see how to Thevenize the given circuit. There are certain steps you have to follow in order to Thevenize the given circuit. So first thing is you have to remove the load resistor after identifying the load value. Okay, and then the second step is find the open circuit voltage, which is also called as Thevenin's equivalent voltage after removing the load resistor across those two removed terminals. Okay, and next step is compute the equivalent resistance. Calculate the equivalent resistance by replacing the voltage sources and current sources with their internal resistances. And the next step is, after finding VTH value and RTH value, draw the equivalent circuit and try finding the current flowing through the load resistor, okay, using the formula IL is equal to VTH by RTH plus RL. Let us apply this Thevenin's theorem on the given circuit like this. This circuit, if you observe it carefully, it is having 3 ohm resistor, 12 ohm resistor and 15 ohm resistor. Now here 15 ohm resistor is considered as load resistor. Okay, and this battery or voltage source is having internal resistance of 1 ohm. In some cases, if the internal resistance of the battery is not given, voltage source is not given, consider it as 0, nothing but a short circuit. If that is current source and it is not given with any internal resistance, consider that as infinity, nothing but open circuit. Okay, so the first step is identify the load resistor and remove it from the circuit. So after doing that, we'll get a circuit like this. See, across A and B are now open. RL is removed. Okay, so then the second step, find the voltage drop across A and B, which is also called as open circuit voltage, also called as Thevenins equivalent voltage. So in this particular circuit, only one mesh is there. You can see A, B, C, D. This is the mesh. Okay, so one single mesh is there. You can use directly KVL. In some cases, depending on the problem, we may use any analysis method like mesh analysis method, nodal analysis method to find the open circuit voltage. So like a voltage drop across the open terminals like A and B. So now in this case we are applying the KVL directly. So applying KVL in D, A, B, C, D. Whatever we are applying this KVL here, we want to find the current flowing through this 12 ohm resistor. If you know the current flowing through the 12 ohm resistor, voltage across that will be V is equal to R and I. R is 12 ohms and I is current. So that VTH is nothing but because this 12 and AB, they are in parallel with each other. So the voltage drop across 12 ohm resistor itself is the open circuit voltage. So to get that, we are applying this KVL. So minus to plus is minus 24, 3 into I, 3I plus 12 into I, 12I. This battery will have having 1 ohm resistance as internal resistance, so that also will consider plus 1 into I is equal to 0. On simplification, we'll get I as 1.5 amperes. So once we got now I value, the current flowing through this, the voltage drop across this is going to be V is equal to I into R. I is 1.5, R is 12. 12 into 1.5 is 18 volts. So we got VTH as 18 volts. Now, third step, find the Thevenins equivalent resistance RTH. To find this RTH, you have to follow two steps. The first thing is replace the voltage sources with their and current sources with their internal resistances. Here in the given circuit, we have only one voltage source is there, and that is having one internal resistance, that is 1 ohm. So we are going to replace this entire voltage source with 1 ohm resistor. See here, I replace the voltage source with 1 ohm resistor. Now if you observe the circuit diagram carefully, 1 and 3, they are in series with each other. I can replace this 1 and 3 with one single resistor, 4 ohm. So after doing so, this 4 and 12, they are in parallel with each other. I apply the parallel equivalent value, means like in order to find the equivalent resistance value. So 4 into 12, I use this formula, 4 into 12 by 4 plus 12. If two resistors are in parallel, R1 into R2 by equivalent resistance is going to be R1 into R2 by R1 plus R2. We'll get 3 ohm resistor. So VTH from the previous step, we got it as 18 volts. Now RTH from present step 3, we got it as 3 ohms. Now you draw the Thevenins equivalent network. Thevenins equivalent network will have VTH and RTH one in series with each other, not only with them, with the load resistor also. So 18 VTH, 3 RTH, they are in series with 15 ohm resistor. So this is what is the equivalent circuit. This is what is called as Thevenizing the given network. So after that you can find IL, the current flowing through the load resistor, using the formula IL is equal to VTH by RTH plus RL. VTH is 18 volts, RTH is 3 ohms, RL is 15 ohms. 18 by 18 is equal to 1 ampere. 1 ampere of current is flowing through the load resistor, 15 ohms. So this is how we can Theveninize the given circuit. Let us understand this concept a little more clearly with one more example in the next part of the video. Thank you.